started?
Remember when we started, there was a delay for the testing. Yeah, that's right. Oh, no, it's showing.
Oh, it's showing?
You're on?
Oh, that's working. Okay, really good. Sorry, it's gonna lag like that. It's lagging behind
Now
us.
you're showing my entire screen.
Yeah, I know. That's how we got it to go. So.
Okay, yeah,
That's a good idea.
yeah, that's right. Oh.
Yeah, that's gonna be the other view.
Oh, I see.
You will be displayed on the lower right.
Yeah, we did. Can you hear it all right from your phone? No issues with the audio? Okay. There's going to be a delay on there. Okay, cool. Want to wait just a couple more minutes?
Just announce that we're starting in a few moments.
We'll be starting in a few moments. We're just waiting for people to get on the stream and trickle in. All right. Well, it's 6:30, so we'll just get this started. My name's Eric Ayers. I'm the current YP chair, section chair for Utah. And welcome to our first event of the year. The presentation is SpaceX Careers in Avionics, and it really has been an unprecedented year. We've had a global pandemic. We've had a lot of things happen, but you know what? Difficult times and challenges are worth facing. And our speaker, Dr. Policy over here, works for a company that no doubt has proven that those challenges are worth facing. And she has graciously accepted coming here, despite the persistent COVID threat, to speak to us all about it. So without further delay, do you want to come up here and introduce yourself further?
So thank you to the section first and foremost, and to Dan and Eric as well for allowing me to come speak. As you probably know, our CEO, Elon, is very insistent that things move forward and we all move on. So I'm happy to be here in person to speak with you, as well as those that are online today. I will create one little disclaimer here, and that is I certainly work for SpaceX right now. In no way is this a recruiting event, but I certainly do want to provide information about how we are structured, how the aerospace industry is structured right now, and maybe provide some insights to some young professionals on what the coming career opportunities are. And that would be the real motivation for the talk. Okay. So a little bit about me. I currently am a principal engineer within that structure at SpaceX. I work in the materials and engineering department. We support specifically the avionics group in their material selection criteria and reliability needs. Previous to working at SpaceX, I was the R&D director for electronics and engineering as well as the aerospace and defense sector. NuSil is now a publicly traded company under the umbrella of Avantor, but they make silicones and various materials for a number of different applications. Prior to that, I was a sustainability engineer at a solar company in Fremont, California called Solyndra. And prior to that position, I held a process engineering position in what we called the back-end packaging. During that tumultuous time at Solyndra, that was during the Obama administration, there was a lot of opportunity as that sector was growing to provide insights, sort of as I am today in avionics and aerospace. I provided some insight into the solar industry at that particular time and wrote a couple of books with regards to how you select materials for solar manufacturing, as well as what we call the back of the systems or the balance of systems, which is packaging of the solar modules. So I wrote two books, one from CRC Press and another one from McGraw-Hill that are available. Prior to that job, I was a consultant at a technical consulting firm called Exponent, also working in their materials division and providing support in material selection. So you can see that my career has basically spun through a number of different sectors and industry, but always with the same theme of materials selection, reliability, and processing. My background is in polymer science from MIT. And I won't say which year I graduated. It's been quite a while, though, I can assure you. But I graduated from MIT, and prior to that, I received 2 bachelor's degrees, one in economics and one in chemistry, from Grinnell College, which is a private college in Iowa. So that's a little bit about me. With regards to how the talk is structured, I've really spent a lot of time reading this particular book. A lot of the text and the thought processes that are in the talk are associated with this book. So it's such an emphasis with regards to the presentation that I wanted to just go ahead and highlight it as the main reference for the talk. It's about lean enterprise value in aerospace. It talks about faster, cheaper, better with regards to the transitions that were occurring in aerospace in the 1990s and 2000. You're going to see this reference coming up, and again, I just wanted to provide it as the main reference for the majority of the topics that we're going to go over today. So one of the things that I found useful in my career is sort of looking at the other individuals within the sector that I'm working and finding out what their backgrounds were and what motivated them. So I wanted to talk first about a lady who is viewed to be the first true female electrical engineer, also an MIT alum, quite a few decades/centuries ago. But she has a number of different accomplishments to her background, which I think from the electronics viewpoint of this particular sector of IEEE maybe have some relevance to you. She patented what was called the Clark calculator, received a patent for electrical power transmission, and probably one of the things that I admire most was one of the first professors at electrical engineering at the University of Texas. So done a number of different things and accomplishments. I think what I take away from her career really is that if you think about when she was getting an education and what she decided that she wanted to participate in or what she has patents in, they were the industries that were starting to grow at that time. Power and electrical transmission was just starting in the early 1920s. Not every house in the U.S. had the opportunity to have electrical power. And so the fact that she was working in that forefront of that technology curve means that she was paying attention to what was important. And I think that you'll always find that there's a lot of opportunities in places where we're just now starting to understand the technology. And I think that was one of the things that I took away from her career. So if I have one central message here, I think for the younger professionals, it's to always pay attention to what's new and exciting. And I think that was certainly even in the 1920s something that she was paying attention to. Speaking of COVID, I think we've all spent a lot of time at home watching Netflix, Hulu, etc. One of the autobiographies, I guess, that I saw recently was on Hedy Lamarr. In great contrast to Clark, she didn't have really much of a formal education. She was self-taught. Certainly she had quite a network within the aerospace community in Southern California. She clearly knew Hughes and Hughes Aerospace, knew a bunch of the engineers there. She's a part of the patent for secret communication systems, which was used to help understand and decode some of the transmissions that were happening in World War II between the submarines, and to understand some of the secret codes that the Nazis were sending back and forth. That frequency hopping mechanism is now used in our everyday life and Wi-Fi, which I don't think that any of us feel that we could live without. The reason I sort of use her as a contrast is I think it's important to sort of recognize as a young professional that you don't have to choose one career. You certainly can do multiple things. And most importantly, it's important to think about what is it that you enjoy doing. If you enjoy doing it, you're likely to excel at it. And if you don't enjoy doing it, you're likely just to show up and punch the clock, but not necessarily enjoy the experience. And certainly life should be about enjoying the experience. I think her contribution is probably one of the most long-lasting contributions. And I think it's long-lasting in part because of not only being able to see the future and see what's necessary at that particular point in time, but because she was just really enjoyed that particular part of electronics. So, two individuals, both very well known in the electronics field, but certainly chose different paths in life. And no one path is the right path, I think is part of the lesson there. Something that I think is also very relevant and can be found in the aforementioned book that I have spoken about is the innovation curve. In this particular type of innovation curve, you'll see the number of firms in a particular sector on the left-hand side and time on the right-hand side. Every innovation, every sector has a tendency to go through what's called the fluid phase, where there's multiple firms going into that particular economic sector. There's a lot of innovation and a lot of opportunity. At some point, though, an emergence of a dominant philosophy/product will exist. And at that point, there'll be a transitional downturn where the number of firms will start to decrease, and then a static phase where you'll see people start to introduce lean concepts and cost reduction measures. So this particular innovation curve will be brought up in our conversation a couple of times tonight. The reason I bring it up right now is I think that these two individuals that I spoke about were thinking of what is the rapid technology, what is developing right now at those particular points in their life. And if you do that, you'll find that there's opportunities for you in those particular sectors that are growing. So it's always important to keep in mind, not just within aerospace, but within any other occupation you want to have, where is there rapid technology growth and where could you make the most impact given where you believe that technology growth is occurring. Something that the Harvard Business Review recently came out with was a similar kind of technology curve worldwide. They took all of the various industries worldwide and placed them onto a graph. Again, sort of a consolidation on the left-hand side and time on the x-axis. They found that it took about 4 years, or not 4 years, but 35 years to go through the 4 stages that I just mentioned. But that time is quickly starting to decrease, particularly with global industrialization. So it may not be 35 years to see that same kind of transition period. What is relevant for this particular discussion is the defense. Right now, they believe the defense sector, which is part of the aerospace larger economy, is in what's considered the balance stage, or that stage where cost is a primary motivator factor. But I think this is a useful curve for anybody right now that's a young professional to think about what opportunities are there globally in stage 1, and is that in alignment with your personal career goals? So I wanted to give a little bit of a historical view of how maybe the aerospace industry has gotten into stage 4 based on the Harvard Business Review analysis. Also from the book, the aforementioned book, if we look at the number of companies that were in the aerospace from the 1900s into 2000, you can see that same sort of curve that we were expecting before, where there was a rapid increase in the number of aerospace companies. There was the emergence of the jet transportation right there in the 1950s, and then a consolidation from the commercial perspective of a number of the aerospace companies. Government intervention, i.e. a number of different government programs and government funding, flattened out the curve so that it didn't follow the national progression down into a low number of firms all concerned about cost and productivity. This is a important sector. I think it's certainly something that I experienced within the solar industry. Whenever the government intervenes, you won't see the same kind of market consolidation. That definitely happened to me in the early 2000s, as there was a number of funding opportunities for the government for US-based companies producing solar. Everything sort of flattened for a while, and then as soon as competition came in globally, there was consolidation of the market. So a couple decades later, I certainly experienced firsthand a similar kind of transition within the market that I was personally involved in. So a good curve to think about and where you are at with regards to your career and what company you're working for. During that consolidation in the 1990s, 2 very large companies, which I'm sure everybody has heard about and has come in contact with, Boeing and Raytheon, really came to the fore sector. I bring it up because a number of the companies that I'm familiar with from reading about the books and going to various air and space museums, you'll commonly come into the McDonnell Douglas airplanes that were flown in World War II and World War I if you go through those museums. That was a company that was purchased by Boeing in the 90s. Hughes, which I mentioned before with response to some of the contributions of the aforementioned ladies, they were absorbed by Boeing. At least one section, which is their satellite sections, was absorbed by Boeing. The other part of Hughes was absorbed by Raytheon, and then General Motors, which I'm sure you're all familiar with, is also absorbed by Raytheon. So that consolidation resulted in some of the very large names that you know about today, and some of the ones historically that you only know about because they still exist in the museums. But I bring this up because consolidation is also part of this discussion, and how it impacts your career is part of the discussion. So post-Cold War performance, if you take a look at this instead of the number of firms on the y-axis, but if you think of it as a relative evaluation from a stock market perspective, in this case we've normalized the stock market with regards to 1989. And what you can see is from the late 1980s into the early 1990s, there were a number of downsizing and mergers that were occurring. And so what ended up happening was the S&P for the general market versus that of the aerospace market, there's a difference. The aerospace is the gray one, and the global, or the U.S. S&P is the blue one. So you can see that as they consolidated and merged, you were actually gaining more revenue from the aerospace sector. And then they started to have terrible performance in the 1990s as a number of the companies started to further walk out of the market, and they actually dipped down below the S&P. The reason I think this is of value is that I keep mentioning that you should be paying attention in your career to where your company is in regards to the 4 stages of potential technology curve and downsizing. The way you do that is you look at what your sector is doing relative to the US S&P, and then you can get an idea of that gauge. So talking a little bit about the current industrial trends, better, faster, cheaper is actually a tagline that was, I think you can trace it back to NASA and some of their departmental goals in the late 1990s. Again, sort of going back to the technology curve, they were trying to not necessarily force these companies into consolidation, but to get the aerospace companies thinking about how can you do things faster, better, and cheaper. I'd say this isn't a new concept, right? You've seen a number of different electronics companies work through these philosophies. And when you think about SpaceX in particular, their idea of reusable rockets, which obviously have received a lot of hype over the last couple of years, that's not a new philosophy, right? It's a call to the same mandate of how you take technology that frankly was around in the 60s and you make it faster, better, and cheaper, which shows you that even a newer company and an older philosophy is applying the same kind of rules, because ultimately the market and the industry is asking them to make sure that they are institutionalizing those same kind of philosophies. So I bring it up because sometimes it feels like if it was tweeted, or if it's on Facebook, or if it's on TikTok, it must be a new idea. It's not necessarily a new idea, and sometimes knowing the historical roots to that can give you some better understanding of the insight to why people are talking about it. So anyway, the aerospace and defense as part of the economy, it's $929 billion in economic output. These are a little bit outdated. This is 2018, 2019 data. A&D, or aerospace and defense, contributed over $374 billion in the GDP in the U.S. in 2018. The supply chain accounted for $208 billion of the A&D contribution. So if you think about that for a minute, what that means is the primary sector that's contributing the 374, the majority of it is coming from suppliers. That means 2 things. One is, if you're thinking about where am I going to have the most economic impact, you're going to have the most economic impact if you're working for a supplier that's going into that sector. And in my previous experience, what that means is your inventions are probably going to have a much higher impact if you're working for one of those suppliers than if you're working for the actual contractor in R&D. The other thing to think about is that's a business opportunity, right? If I'm running an organization and my supplier is making up a larger part of the GDP, then that means there's revenue there that I'm not capturing. And so that means that those people are going to start thinking about, does it make sense for me to continue to pay supplier A to make this for me, or is that something that I'm going to want to do? So again, so it gives you some insight both to where maybe you want to go in the market and what you're going to view that the stockholders will want to go in the market. With regards to trade surplus, 90 billion in trade surplus. They generated a positive trade balance of nearly 90 billion. This is sort of showing you that there is an opportunity to have a global influence within the aerospace and defense market. I'm going to sort of step away from the controversy associated with that. You can definitely go to 60 Minutes, some of those older episodes. You can go to Hulu and Netflix and find that there's a number of government contracts that are being supplied overseas now. There's some question as to whether that makes sense with regards to some of the technology associated with rockets, et cetera. But there's certainly a global impact that you make within aerospace and defense. But with regards to what the numbers are, regardless of the controversy, in 2018, it's only 9% of U.S. exports. So it's still going to be a largeable amount of money, but certainly not the largest U.S. export by any means. So I wanted to give a little bit of a perspective on supply chain within the aerospace and defense sector, since now I've shown that there's an opportunity there for both you and potentially the shareholders of the ultimate aerospace and defense organizations. So we usually talk about these as Tier 1 and Tier 3 suppliers. There's some names here which you may be familiar with, or maybe you've driven down the road and seen the marquee. Some of the ones that are very familiar with in Southern California is Triumph and TransDigm. Both of those are very well known. But a Tier 1 and Tier 2 is going to make pumps, motors, controllers, actuators, sensors, cables. Those are usually what they're going to do. The Tier 1 will start to integrate what's made from a Tier 2 and Tier 3 supplier. So they'll be coming up with the structure of the controls, the hydraulics, the gears, the interiors of the aircraft. And then the OEM, which I'm sure you're familiar with because we've already brought them up in this conversation, will be responsible for the design and assembly and integration of the much larger aircraft or missile, etc. In the commercial space, the OEM then services the ultimate entity, which provides services and leasing to the generic public, which is Delta, United, Emirates, American Airlines, all those service providers that we all used to be very familiar with prior to the pandemic. So when thinking about, again, the opportunities, it's good to think about, well, where are you in the market structure? Where is your job opportunity in the market structure? And this gives you some insight to hopefully to where there might be some shakeup and consolidation. Some notable considerations with regards to the stock portfolio within aerospace and defense in the United States right now. You'll find that Boeing is really one of the largest dominators. Again, not just because of their consolidation of the market in previous years, but in the most recent years, they've targeted a number of places where they wanted to move. So Boeing, sitting in the OEM category, looked backward and said, there's some suppliers that we want to assume. And then looking forward, they said there's some service providers that we want to also integrate into. So they're vertically integrating up and down within their supply chain. So in 2018, at about over $4,750 million, they acquired Embraer with regards to regional air travel. Previous to that, they also acquired XLX to further diversify their supply chain and grab some of the revenue that company was getting. Similar things happened, and the reason I even pulled these particular ones out of 2016 and 2017 to highlight is you can see that Rockwell Collins used to be pretty big, right? They actually acquired BE Aerospace, which was known for interior aircraft design. And then not even a full year later, they are acquired by United Technologies, in part because of their acquisition of BE Aerospace with regards to interior design. So just because you're the person that's sitting there in a company that purchases another company, that doesn't mean that you won't, in the future, near future, be further consolidated into the supply chain. A number of the companies that I've highlighted here, they were always the consolidation within Tier 1. The reason I bring that up is the consolidation that I was talking about that would occur post-Cold War was a lot of consolidation within the OEMs. Once the OEMs consolidated, they had to go somewhere else to further reduce the market. And so you saw the supply chain starting to get reduced in the early 2000s. And that's really where it continues to be constrained, is supply chain integration and reduction. What this means also is, I've talked a little bit about the technology curve. That technology curve then applies not only to each of the different sectors within aerospace, but it applies to each of the different sub-tier suppliers within aerospace, right? You can imagine that there's a technology curve associated with interior designs of aircraft. And at some point, a dominant design occurs, and then a consolidation within that particular sub-tier. So don't think of technology curves as one single technology, and don't think of them as a single industry. They certainly apply to multiple industries within the same space. With regards to the current performance of aerospace stock, I've only graphed here 2016 into our current 2020. You can see that we were actually doing pretty good. Again, sort of like what you saw in the previous graph from the aforementioned book. The S&P for aerospace was outperforming the generic S&P. And then as we hit the COVID crisis, both of them dropped. And now they're on a very similar trajectory, which really just sort of shows you that people are uncertain not just about the generic stock market, they're concerned about all stock markets. And so I think we're eventually going to hit, right, a similar kind of consolidation that you've seen in the past, but with the global pandemic occurring, it just sort of set us into a different trajectory. With regards to who makes up the graph that I previously showed you, as I mentioned a few slides before, Boeing makes up the largest with regards to the OEMs. They're making up 19% of the aerospace and defense sector when you're talking about publicly traded aerospace and defense. And this is who you'll find in the index that I just showed you. Raytheon, again, because of their consolidation post-Cold War, they're going to make up the second largest part of the sector at 17%. Lockheed and Martin makes up 7%, and that takes you out of the first three from the OEMs, and then you'll see a tier 2 and 3 showing up in TransDigm. Now this is important, right, because now we're starting to see some of the suppliers starting to show up in the public trading space. The rest of the two OEMs that you'll see are General Dynamics and Northrop Grumman, and then Teledyne at the very bottom as a tier 1. So this is currently who you're going to find in the publicly traded market. And you're going to find that the bigger you get, the more exciting you are to both private equity as well as to consolidation. So DoD programs, Department of Defense programs, make up a large part of aerospace and defense. Makes sense to sort of figure out who's getting business and then filtering it through to the supply chain. The majority of the companies that existed within the S&P Aerospace and Defense Index are also going to show up here with regards to how much they get from the Department of Defense. So Boeing, one of the largest, only really gets about 13%, while Lockheed and Martin gets about 20%. Then you'll see that Northrop and Grumman, they get about 6%, and then United Technologies 3%, and the remaining of the DoD contracts go to 52% of the 52% of the remaining contracts go to the remaining companies, which are smaller companies. As obviously the larger the company gets, the more of the pie they get, right? And so this gray area is opportunity, right? It's opportunity for people that want to enter the market. It's opportunity for people that are already in the market to gain larger and larger sections of the contracts. So I did talk a little bit about consolidation with regards to what was happening in 2016, 2017, 2018. If you were to Google right now and look at what is happening today, you're going to find two really big changes. One was United Technologies and Raytheon. Raytheon absorbed United Technologies in April the 3rd of 2020, creating Raytheon Technologies. They're one of the largest aerospace and defense companies as a result of that merger. They have about 195,000 employees, way more employees than I've ever worked in or with, and make about $74 billion with regards to 2019 net sales. Also would be much larger than any organization that I've personally worked for. The other interesting thing, and I say this because I do work for SpaceX right now and I am paying attention to who competitors are, is Northrop Grumman purchased Orbital ATK back in 2018. I brought this into the discussion because being from the Utah sector, I'm sure you're familiar with Orbital ATK up the street. I was familiar with them because around that time, I actually interviewed with them and they mentioned this merger and I said, that's really interesting, I think I'll pass. And I'm going to tell you in a few slides later why I decided I didn't want to go into an organization that was about to be merged with Northrop Grumman. It wasn't Northrop Grumman in particular that I was concerned about, but the merger concept I was concerned about. And so I'll go into that a little bit in a little while. But the reason it's important from SpaceX's standpoint, and frankly from the aerospace and defense sector's standpoint, is, as you may know, Orbital ATK is one of the only companies that supplies solid rocket motors. And as a result of the merger, the FTC is supposed to enforce that Northrop Grumman allows any of their competitors to have access to the technology that Orbital ATK has on a non-discriminatory basis. So they are responsible for making sure that they still provide that technology to the rest of the competitors. Whether or not we all want to believe that that's being enforced is totally up to your own discretion, but it is part of the agreement within the merger that occurred. It, as I'm going to talk about, has a very important strategic influence on bids for DoD contracts, and that's part of the reason that I showed you the pie. That pie is a little old. I'm sure that that's very different today with some of the mergers that have occurred. Even with this merger, though, still not anywhere close with regards to the size of Raytheon now. It's 12,000 employees, $293 million in 2019, so still not the largest organization, but probably not paid very close attention to, frankly, because they were small when they did this. But has a lot of important technology and strategic opportunities for Northrop now that I'll show you in a few minutes. So speaking a little bit about why I think this consolidation is important for a young professional and something that I was considering as I was moving through and thinking about my next career move. My personal experience has been a thumbs up, a thumbs down, and a thumbs neutral when it comes to consolidation. I've been in organizations that have consolidated, and I've been an equity holder within that organization when it's consolidated. And sometimes that can be good for you, and sometimes it can't. So if you were an equity holder in Raytheon when they merged, you actually would not have done so well. Your shares would not be worth that much. If you were an equity holder within United Technologies, you would have actually done really well because your equity would have been higher in returns. A lot of times that has to do with the amount of debt that your organization holds as it goes through that merger. If you are owner of an organization that holds more debt, then you're going to hold less shares in the combined entity. If you are in part of the organization that holds less debt, then you are going to hold more shares in the combined entity. So something to think about if part of your future compensation, if your retirement is associated with the amount of equity you have in the company because you're part of the equity share program, when something consolidates, there's not much you can do at that time, but you want to pay attention to those meetings, even if you're young, because that is your future. And that's usually how most companies try and compensate you today, is through equity share. One of the things that I found is that when they consolidate, naturally, there's an expectation of redundancies. In fact, when a company consolidates, they tell their shareholders, hey, don't worry, there's going to be a consolidation. There'll be a return on EBITDA, or earnings before taxes, because we're going to have a workforce reduction. Knowing that firsthand, I think will make you feel a little bit better with regards to whatever your outcome is with regards to that merger and what your position is in that organization. But you should just be aware of it, right? That's just a natural expectation when two things come together, that there will be a consolidation of what are considered to be redundant resources. Even if in practice they're not redundant, on paper they may look it, so there will be a reduction. A normalization of pay scales, something to pay attention to as we think about the global economy. With the pandemic, right, everything's going virtual. You should start thinking about yourself in the much larger global economy, not in the Utah economy, not in the US economy, but in the global economy. And what that means is, if I'm a global manufacturer and I then acquire a small organization within a regional area, I'm going to enforce upon that regional area the same kind of pay scale structure that I use globally. And that can be good for you or bad for you. Either way, your human resource benefits are now going to be tied to a much larger organization that's taking control. With regards to new philosophies, I've always found this as being a good thing, particularly if I'm in a smaller organization and they're merged with a large organization. New learning opportunities, new things, new ways to think about what you are doing, to create efficiencies in what you're doing. But I've always been welcoming of an organization that at least wants to train me in a new philosophy, because it's a new way for me to learn and practice those skills. So I think you'll find that also as part of the cultural change. So one of the individuals that's discussed in the book, and I will admit a controversial individual, Dan Burnham from Raytheon, he was responsible, he was the CEO in charge during this time period. I believe it was known that Raytheon had about $1 trillion in mergers. They were very much in debt. They had all of these different sectors that they had purchased. In fact, there's a book called Good to Great. It's a good read. It talks about how a company should think about what companies to actually merge with or to consolidate with. I would say that Dan and the stockholders didn't think too much about that particular book, because at this time, Raytheon had, a sector that was working on dishwashers, right? It wasn't like all of it was aerospace and defense. They had taken some of their technology and gone into commercial electronics and appliances. So while he was thinking, how should I integrate all of these different companies that we've purchased, he specifically pioneered the Raytheon Six Sigma program, which had 5 core principles listed here. Specify the value based on the customer, so think outside of the walls. Think about what your customer wants. Identify the value stream and how you eliminate waste. This is sometimes can be associated with a workforce reduction that I mentioned. Make value flow to the customer and make sure the customer is pulling you to that, right? Don't build something because you think somebody wants it. Build it because they actually want it. Involve and align and empower employees. This is something I've heard over and over again. That all decisions shouldn't be made at the top by management, but that people should be thinking about what is best for the organization, what's best for the company, what's best for the customer, and then employing those principles. And then continuously improve your knowledge, some of it funded by the organization and some of it funded through your own exercises, i.e. in some of these kind of associations that you're currently familiar with. What is important from an employee perspective is these principles were aligned with the annual plans of the organization. They were aligned with the goals, and then they were part of the performance measures of the actual employees. So you would be graded and your annual bonus would be based on whether or not you applied these 5 principles. So just an example of some of how the culture can change based on a change in the organization and mergers that are occurring within the organization. Again, 5 being an example of where you can learn and start applying new knowledge from the organization. The one comment I'll make about Dan is if you really Google too much about this, Dan got in trouble, and about the early 2000s, he ended up resigning from Raytheon. He got in trouble with FTC because he did not allegedly honestly communicate the revenue associated with one of his subdivisions, which was an aerospace avionics subdivision. So they looked at the books and decided that he did not communicate the revenue correctly. It was actually not making as much money as he projected. And so he ended up leaving Raytheon at that time. So I just bring it up because, not necessarily because I think that there's any guilt or innocence there, more just because I think there's a lot of complexity associated with these large organizations and trying to police them both internally and externally. And they're also very complicated organizations. Of course, the buck stops with the CEO and Dan, but they can be very complicated organizations to even maneuver within as the employee, let alone if you're in the management structure. With regards to, again, where we're at with the technology curve, I mentioned to you, I felt like the ladies that we discussed at the very start of this lecture were really thinking about the fluid phase, the rapid technology. At this point, right, as we get into the early 2000s, we're definitely seeing an emergence of a dominant design and a few behemoths within the organization. And you're starting to see people start to think about the shifts to process, reliability, Six Sigma, improving the process, and then ultimately, because of that, thinking about the cost associated with those processes. So let's talk a little bit about current events here in the last part of the discussion. I wanted to talk a little bit about the different sectors. Certainly, SpaceX only really works within a single sector right now. The aerospace industry really is made up of 4 principal sectors: the commercial aviation on the left-hand side, military aviation, some of the discussion that we had about the Department of Defense is associated with that. Space exploration, certainly contracts with NASA would be that sector, and then rockets and missile defense. As I was thinking about transitioning out of a company that made silicone for medical devices, I was thinking about, well, what is aerospace? I think it can be defined in a number of different ways. Anything that flies in our atmosphere is basically defining aerospace. And certainly within avionics, any electronics needed to support that flight is associated with avionics within aerospace. So keeping the thought fast and lean, what you'll find right now in the commercial aircraft sector is lightweight and lower cost. The 2 large companies that really have dominated that space is Boeing and Airbus. Boeing, if you Google too much, you'll find a lot about the 787 Dreamliner. I think what's interesting for the electronics individuals within the room and online tonight is some of the difficulties, right, that happen with the 787 Dreamliner. Certainly one of the issues that they had early on that you might be able or familiar with is the lithium battery fires that occurred. ANA was the main service contractor for the Boeing OEM 787 Dreamliner. Certainly an opportunity, right, for learning within that sector of how the design didn't quite meet the production needs and certainly the reliability needs, but certainly something that had very much to do with electronics. The other thing that Boeing is really touting is electrically powered compressors. This is how they get to a lightweight, lower cost design. Another opportunity, right, within even a mature organization or mature sector to think about how you could be part of that electrically powered compressor that reduces the cost of energy and therefore the cost of the design of the aircraft. From Airbus, also very conscientious with regards to the A350, where they're trying to decrease costs, but trying to decrease costs from a materials perspective, which frankly is something that's near and dear to me. Carbon reinforced wings, decreasing the cost for fuel associated with a more lightweight design. If you think a little bit, we didn't talk about them specifically as a supplier, but Rolls-Royce, those engines are part of the supply chain and part of an important part of the supply chain with regards to executing against this lighter design for Airbus. Within the military aircraft space, the three large organizations that you'll hear a lot about are Lockheed and Martin with the F-35 Lightning II design. In that case, this is really a replacement vehicle for the F-15C and F-15D. So they're interested in replacing some of their older technology. For Northrop and Grumman, the 24E2D, I mentioned a little bit about the opportunity there for external exports. Most recently in the news, Congress allowed for this particular technology to be exported to, I believe, France. So you'll see that this is one of the ways that Northrop and Grumman is increasing their revenue. This particular technology provides advanced warning for sonar detection in the Navy application, so the Navy is the main source of that program. And then Boeing, the F-15EX, with regards to them, they're interested in heavier ammunition, a lightweight design, lower cost, and electronic warfare capabilities. So just as you see the IT space changing in the global environment, so too are those electronic requirements coming up in the military aviation space. One of the things that certainly SpaceX has created some buzz about is commercial cargo spacecraft servicing the ISL. NASA's Commercial Resupply Services Program was actually bid on by 3 different organizations: Crew Dragon, or Cargo Dragon, which is SpaceX in the center there, the Dream Chaser from Sierra Nevada, and then Northrop Grumman. And I mentioned before that Orbital ATK was important as an acquisition for Northrop Grumman. It was important because it got them into this particular sector. Otherwise, they would have not had any name recognition within the spacecraft application space. The other thing that I think is interesting here is you always think about space applications and you think Hubble telescope, you think of things that are happening decades later, you're still getting information out of them. The commercial cargo spacecraft sector has really changed its design to 1 to 2 years. This is a very change in reliability requirements, design requirements, and is altering sort of how the market thinks and how they develop processes. The other place that you'll see our name is launch contracts for military hardware. Of course, military hardware not being well defined. United Launch Alliance is in competition with SpaceX, who's in competition with Northrop and Grumman. Again, ATK being the important strategic merger, which then allowed Northrop to get into this space due to their rocket technology. Just recently, on the 20th of August, it was announced that ULA and SpaceX both will be providing the majority of that DoD contract, 60% which was awarded to ULA and 40% which is awarded to SpaceX. Might be interesting to note, if you read that particular article, SpaceX received 0 of the original DoD contract that happened about 8 years earlier. They ended up suing the government with regards to fair trade associated with those programs, and a few years later ends up coming up with a contract. So you can draw your own conclusions with how those contracts are divided or how you interact with the various government agencies in order to get those contracts. But what I would say for you as a young professional to think about is networks are important to you. They're going to be important throughout your entire life, who you know, where they're at, and likewise in business, contracts and contacts are very important. So something to take away from that particular interaction. With regards to missile contracts, there's two large behemoths here, Raytheon and Boeing. Raytheon in June of this year received $2.3 billion for radars for the Terminal High Altitude Defense System. Boeing on May of this year received $3.1 billion for cruise missiles. Now the interesting thing here is what I said earlier was Northrop has a lot of strategic acquisitions in their portfolio. That contract that Boeing won bumped down, and they subcontracted out to Northrop to provide, I think it was at least about $1 billion in hardware for that much larger cruise missile system. So again, you'll see a lot of partnerships within different organizations. It's not always a bad thing if your competitor receives a larger contract, because if you have strategic acquisitions that they need access to, then that will provide some benefit to you. So at the last part of our talk here, let's just talk about some desired skill sets for electronics engineers within avionics and aerospace. Just to give you a little bit idea of the job market, again, pre-COVID, things have obviously changed a lot, and I think are continuing to change in the coming months. But there were 2.5 million jobs in 2018. The aerospace defense industry was that large. 20% of the total manufacturing jobs within the U.S. Came from that sector, so that's not too bad. With regards to a lot of manufacturing jobs going overseas, at least 20% of our current jobs were in that particular sector. And then about 881,000 with regards to end use, while the supply chain is over 1 million jobs. So again, little thought there might be more opportunity for you right now in the supply chain than there is in the ultimate contract provider. 237 billion in wages, 7.7 increase from 2017. So just like the S&P was increasing, the wages for those employees were increasing. And then the average worker salary is 87% higher than the national average. So not too bad of a sector to be in. With regards to where those opportunities are in the US, you'll find that a lot of opportunities sit within California. The tweets are real. If you're working for SpaceX, you're going to have a lot more opportunities in Texas today than you had in California today. So there's a lot of opportunity in Texas, both growing as well as established jobs. There's also quite a bit here in Utah, so not to dismiss, and then a lot within Washington and obviously on the East Coast. You can see sort of the mean wage, not too bad with regards to some of the other industries and where you could start, but certainly well within the above the national average. So talking a little bit specifically about avionics, there's a couple careers that you could consider. Software engineers, those individuals that are making the software that talks to the missiles, that talks to the different computers that are necessary for government satellites, etc. Hardware engineers, that's a picture of harnessing wires and cables along a part of the aircraft. So there's a lot of opportunity there with regards to design and mechanical engineering skills. Manufacturing engineering, as I mentioned, there's a lot of manufacturing jobs, a lot of vertical integration, a lot of opportunity to build things. And then electrical engineers, certainly there's a lot of opportunity to come up with the electrical hardware and how all of the different PCBAs are created, etc. And then reliability engineers. Certainly this is a sector that even though, particularly I mentioned that the space cargo flights only required 1 to 2 years of reliability, that's still a very dynamic environment, a lot of vibe, a lot of heat, a lot of vacuum. So there's a lot of opportunities there for reliability engineer. With regards to the space industry, where were the largest number of failures over the last couple of decades? A lot of them actually occurred within the avionics section of the aircrafts, right? So communications that I talked about, software and computing, A lot of it associated with the electrical systems and navigation systems. So again, from a reliability perspective, not only a lot of opportunity to design those systems, but a lot of opportunity to be a reliability engineer, improving upon the issues that have been experienced in those sectors. I mentioned the need to think forward and how companies can help you learn new skills. Design for reliability is one of those skills that you'll use within the aerospace industry. If you think about the design phase, you start with a concept, you build a prototype, you go into development and maybe make a few of those prototypes. Then you make into manufacturing phase where you're doing a pilot scale, and eventually that pilot scale moves into full production and you have a support phase where you're monitoring the health of your design. When you think about reliability in that concept, when you are first going into the concept, you should be thinking about what are the reliability concerns, what are the objectives of what you're trying to accomplish, identifying the right risk, starting to find those risks in the prototype phase, quantifying the risk, doing more testing, and then ultimately monitoring that as it moves through the manufacturing and production phases. Now, each part of the different sectors that I talked about will have a different reliability requirement. This is what you see in passenger aviation, where there's essentially 5 different requirements for reliability. There's a first level of catastrophic failure, where that should happen in less than 1 of 10 to the -9 flights, hours. That would be a full failure of the computer system. That would be an ultimate issue and complete over failure. The least is to have no impact. I know it might bother you, but if your computer system in the back of the headrest isn't really transmitting your DirecTV or your movies, that's really not considered to be a large impact from an aviation perspective, right? So there's different gradations within this industry with regards to failure. NASA defines reliability objectives for the space industry with regards to 3, normal, which means no failures, fail operation, 1 failure, and fail safe, where you have to abandon the mission and there might be a loss of a vehicle, but you'll get a full safe crew return. The way they designed for this reliability is they designed redundancy in their avionics systems, having 3 computer systems instead of 1 in case one of them were to fail. Now that could be an additional cost which has to be balanced with regards to reliability. What you'll find most people in the space industry using is a program in the concept phase, which was actually pioneered at the University of Maryland called the Sherlock program. It can provide a PCBA or electronic engineering design on the right-hand side. You can have a number of different assessment options, thermal cycling, vibration, vacuum, to come up with failure rates that you expect for each of those different assessment options, which then combine to 1 overall score for reliability. This is a common avionics application of the concept phase and looking into potential risk. The other thing that you'll think about is quantification isn't equal to acceptance with regards to the sector that you're thinking about, right? For example, in thermal cycling, you'll have what is the predicted thermal cycling range. You'll add on a couple extra Ds for acceptance criteria and then a couple more degrees for qualification. That qualification criteria is what you'll be using in the prototype in the early stages of the pilot phase, and then acceptance is ultimately what moves you into production and long-term reliability. This is going to happen both in terms of thermal cycling, in terms of vacuum, and in terms of vibe with regards to how you come up with your reliability program. Finally, combined stress states. You'll find people go do vibration, they'll do thermal cycling, they'll come up with a model of those failure histories, then they'll self-impose those 2 to come up with a superposition and a lifetime prediction. A lot of what's happening in the industry now is actually coming up with software, hardware that can combine vibration and thermal cycling into 1, so you don't have to do a superposition of the 2 different failure modes at the end. So just again, is sort of how the engineering is starting to evolve and how that evolution can be something that you can participate into with your career design. Now, all that being true, reliability, sometimes the simplest of manufacturing issues, will underscore all of the reliability testing that you do. This is a picture of a flight from a Russian spacecraft. If you YouTube this, this happened in the early 2000s, I think it was 2003, 2004. What happened in the spacecraft is somebody actually had inserted the altimeter in the opposite direction. So as the rocket took off, it actually thought it was upside down. So it spun itself over and then crashed into the Earth. So you can try and think about the design as much as you want, but at the simplest of production failures can result in a complete failure of your subsystem. I'm not saying that you shouldn't think about reliability, but just constantly design for simplicity in manufacturing as well as design for reliability. So revisiting the innovation curve, we've transitioned now into a part of the aerospace and defense sector, which is really thinking about the shakeout competition is starting to be removed, and a lot of people are moving into process simplification, reduction in cost, and you're seeing the number of firms starting to decrease, both at the OEM stage as well as in the supply stage. So in summary, I know I'm a few minutes over, so I just want to leave you with some closing thoughts here. Pay attention to the trends, find opportunities, avoid cultural mismatches for you. Find something you enjoy doing and make sure that's part of your daily activities. In aerospace, your work opportunities will be impacted by the political climate, the opportunities for the Department of Defense. Programs will change with each of the individuals that take office. So expect that kind of shakeout in your career. But always think about where your company is in the technology curve that we discussed. And then finally, with regards to the different sectors, they'll all be experiencing different parts of that technology curve. So you can always think about jumping to a different part of the sector if you're at maybe a steeper part of the technology curve where you could add more value. But prepare yourself for success by understanding some simple concepts like design for reliability, design for manufacturing, and even the design phase in general, which isn't usually something that's covered in most academic institutions. So those are some closing thoughts. Happy to take any kind of questions that you may have, and appreciate your attendance. Yes?
Dr. Bliss got a question. So on the slide about Six Sigma, you talked about 5 principles. You also talked about reliability and based on statistical process control. And I wondered, why do you think that the 5 ideas have no statistical basis at all?
I think the 5 ideas could have statistical basis. My personal experience has been when trying to integrate the customer viewpoint into the philosophies of the organization, it's difficult for most organizations to look outside their walls and come up with the statistical probabilities of servicing that particular customer. I've seen a lot of organizations try and institute Salesforce, institute various data collection services to come up with those statistics. And the statistics have a tendency to be inaccurate and then move the organization in the wrong place. So I think there's some places where they try and create statistics. I think the statistics are hard to get a handle on when they are data that's generated outside the walls of the organization. But certainly from an engineering standpoint, applying those principles is the easiest way to make sure that you're actually adhering to the principles that were laid out there with regards to what they were trying to do, particularly at Raytheon at that time.
So we do have a question from someone watching the stream. If you were in college wanting to get into the aerospace industry, how would you go about it? Skills, networking, where would you start, and how do you advance?
Good question. I think, sure. The question, Eric, do you want to maybe come closer since you have it on your phone?
All right, so our first question from the audience is, if you were in college wanting to get into the aerospace industry, how would you go about it? Skills, networking, where would you start, and how do you advance?
So because it's a mature industry, I think there's a couple opportunities. Certainly these organizations do recruit within the various universities. I personally found it most useful, frankly, to go to the networking opportunities where I would find the individuals and the companies that I was interested in. So there is a aerospace and defense organization there where you can meet people in the sector that are currently working in these industries. I think that gives you a good perspective of what actually happens at the company, so you make sure that there's a good cultural fit for you. All of these companies I've talked about you can find on Indeed and various career websites as well. But they also provide internship programs. Interning in an organization is probably one of the other ways, if you not have any networks, to make sure that there's a good cultural fit for you and the organization. Those are some potential opportunities for how you get into those spaces. The other thing that I would think about as you think about like how your career would proceed, I think it's important to think about some of the principles that we've talked about here. If you're in a small organization, you're going to have a lot of opportunities to work on a bunch of different things. The larger the organization, the more likely you're going to be asked to work there for a specific skill set. If you're interested in doing one thing and doing one thing well, then you'll want to go into a large organization. If you're interested in doing a number of different things, then you're going to want to move into a smaller organization. So your career path will be very different depending upon which type of organization you go into. But certainly, if I wanted to go into the aerospace and defense market, the first thing I would do is make sure that I networked with the right individuals through LinkedIn or through professional networks. Yes.
How do you tell technologies most trending, most likely to be
So the question is, how can you determine which technologies are trending and which ones are most likely to be going through change or about to change? So I guess with regards to which ones are trending, to be honest with you, the ones that are trending are the ones that you're going to find on social media. The ones that have the greatest amount of opportunity are the ones that are chatted about with regards to LinkedIn, TikTok, Facebook, things like that. I think you'll also find the ones where the private equity organizations are driving funding are also going to be the ones that are trending. You can go to the various indexes that I talked about, the S&P indexes, and you can find where those private equity companies are spending money. Where they're acquiring companies, and they do acquire companies within the aerospace and defense market, even though it's a mature market, those are the sectors which are going to be receiving lots of infusions of cash. And when you're working for an organization that receives infusions of cash, either from the market or from the private equity market, there's going to be a lot of opportunities for you to basically decide how you want to work in that organization and to provide value in that organization. So you want to pay attention to where people are investing, both the public investors as well as the private equity organizations with regards to the technologies that are trending. And you're also going to want to pay a lot of attention to social media, as well as mainstream media. A lot of the articles that I've talked about here, a lot of infusions of cash, the DoD programs, those are all associated with things that you can find in New York Times and the mainstream media as well. So for instance, just as a quick example, you can find the articles, right, about some of those contracts. You can find the discussions about the commercial aerospace industry. I recently had then looked at a job opportunity with one of the companies that makes the engines, and the job opportunity for me was to come up with the composites that are designed in the engines. So I knew about that job opportunity because I was paying attention to the airline industry and what kind of aircrafts were coming out, right? And I saw that they were lighter and cheaper and they were using composites. Those composites are the same composites that have been used in the aerospace industry, in the space sector for decades. And so having an understanding of reliability, having an understanding of that sector wanted to go to a lighter weight material meant that there was an opportunity for me to start going after those particular sub-tiers and introducing myself for particular career opportunities. So you can even just pick up your Sunday newspaper, the New York Times, Wall Street Journal, and see from those articles sort of how industries are trending and where the opportunities might be. So I only heard a part of that. You said the opportunities were in the tier 1 suppliers?
So yes, we are looking at most opportunities, or at least the most impactful career opportunities tend to lie within those companies that are out of the supply chain.
Yeah. So for those online, the question was with regards to whether or not I believe that the most impactful career opportunities exist within the supply chain and the tier 1 suppliers. And the answer is yes. The reason I believe that is the OEMs will be awarded the contracts from the various defense agencies, the Navy, the NASA, Air Force. What that means is the technology is usually then made by the tier 1 and tier 2 suppliers, and then integrated by those OEMs. So while they hold the design, I think there's a lot of opportunity for individuals to work in the tier 1 and tier 2 supply chain to come up with new sort of sub-assembly designs that are impactful for the ultimate goal of the larger contract. Because a lot of that work is happening in those suppliers, I think there's a lot more jobs, and I think there's a lot more impactful jobs. But the answer is yes. I think that you'll find less consolidation as well. Even though they're starting to consolidate in those areas, you'll find a lot more jobs in that area right now.
Okay, so we do have one more question from the audience. Well, we figure out why this thing is doing that. They want to know if they can get any contact info for networking purposes.
Yeah, I mean, I think there's a couple of different things. I've only really been focused on the aerospace and defense contacts within Southern California, to be fair to those that are online that I'm sure are in a number of different geographic locations. What I can do is provide to you, Eric, the various professional industries that I was talking about, the links to those websites. Certainly within IEEE as well. There are a number of people that work within aerospace and defense, so please don't overlook the opportunities within your current networking group. I know it's going to be difficult right now with regards to COVID to know exactly who's here and what opportunities exist, but certainly within IEEE in and of itself, you're going to find a lot of people that work in the tier 1 and tier 2 and tier 3 suppliers. So please take that into consideration. But certainly I can also provide certain other professional networks that exist within the aerospace industry from a national perspective that might be helpful. I'm going to also just throw this out here. I was actually at the Lions Museum, which is right next to the Santa Ana Airport, also called the John Wayne Airport in Orange County. I was at the Lions Museum, was looking at an aircraft, didn't really know what it did, thought it was sort of neat looking. And a guy came up to me that was a docent who was like the VP of Lockheed back in like 2005, right? So there's also opportunities around that you may not even be paying attention to. He was a great contact for me to understand not just how that company had evolved, but what other opportunities there are. The other thing that I would say is in your alumni organizations, certainly within MIT, there's plenty of people that work within aerospace. Also think about which organization or which institution you're from and connect with your alumni and see whether or not they're part of the network that you want to get involved in. Certainly a lot of people from MIT are from the aerospace department, so there's a lot of opportunities there, but there's a lot of aerospace companies and aerospace departments throughout the various institutions within the U.S., so also consider that as well.
All right. Is there any more questions?
I have a question though. So we talk about the tier one suppliers as well as the OEMs versus the country, the U.S. government or the airlines, for example. How? I guess I'm always interested in how do you, from engineering perspective versus where the customer needs are. It's actually kind of a big gap, right? Because the customer kind of have a direction. They want a cheaper, lighter, more fuel efficient, and not there. They just want an efficient plane with low operating cost. And how does between the OEM and the tier one supplier, especially you mentioned the tier one supplier would be maybe more opportunity for to fulfill the need. And how does the industry or the system work in aerospace on like translating the need down? Because it's basically someone need to have one idea and driving a design direction in a way, like whether you can say Boeing want to do the electric compressor with more efficiency. They come like part of it. I'm sure there are other technologies that will might drive similar result later. How did you kind of navigate yourself throughout what would be the kind of big hit, that kind of stuff?
So I'd say one thing to keep in mind, the question for the online individuals was with regards to the tier one suppliers. How are the requirements appropriately communicated from the OEM to the tier one suppliers to make sure there's efficiency in the thought process of what the OEM wants to build versus what the tier one supplier is providing. One thing to keep in mind is when a aerospace and defense company is making something, they might have a preferred supply chain, but they certainly go to everybody, right? And they'll say, this is what I want to do. And whoever gets them what they want fastest is the supplier they ultimately go to, right? So never think that just because you're in that supply chain, they're only talking to you, because they're not. They're definitely talking to a number of different people. I think for you as an employee of one of those companies, what you really want is you want somebody from that OEM just to say, hey, look, I think it needs to look like this, and it needs to be cheap. And then you want to have that design capability to say, here's how I think you make this gear cheaper, or here's how I think you redesign it to be cheaper. If you have a good working relationship with the customer and your preferred supplier, you're likely to have that latitude. And certainly if you're going to be interviewing with certain potential job applicants and hiring managers, it's a good question to have with them of sort of like what their latitude is in that design and how they influences people's design. I can tell you from a materials perspective and being part of the materials supply chain, what will happen is somebody will come with a design and they'll have a cost target. And then they might say, I want to make it with this adhesive. And then I will go back and say, yeah, you could make it with that adhesive, but I could have you use this adhesive instead and reduce cost by 50%. So I think knowing their targets, you can figure out how you can help them get to their targets. But the onus does exist on the supply chain to influence the customer on how to get there. There's a well-known term called knowing the voice of the customer. That's not to say that I should be able to think how you think. It's that I should be able to listen to what you say, understand what your concerns are, make your concerns my concerns, and then figure out how I can help you with your concerns. There are certainly some OEMs that are going to come to you and say, hey, look, I just want you to make it with this widget. I want you to make it with this design. That also exists within the supply chain because maybe those employees used to be in the supply chain because there's been consolidation and now they know what they want. That's sort of contract manufacturing, which is a lower budget, which isn't something that's very fun for an engineer to participate in, but certainly does exist within the market. So I think the true answer to your question is listening skills, and then knowing your own capabilities so that you can move their requirements into the space that they want them to be in.
Any more questions?
I have one more. I'm kind of curious.
Yeah.
So you mentioned you were interviewing for orbital agency at the time when they were first coming off, and then it sounds like you interviewed with SpaceX and other companies at the same time as well. Knowing was their strategic design, if this happened like now, like in the position now, what were your considerations different? Like when you work for Northrop Grumman because they have the ground strategic space versus SpaceX.
So for those on the line, the question was with regards to my previous employment opportunities. My opportunity with ATK Orbital occurred exactly at the same time as my opportunity with SpaceX. And looking forward, if that same opportunity were to exist today, would I still make the same decision as I did a couple of years ago? I'm going to be honest that for me, I'm at a point in my career, I'm basically in the middle of my career. I think I have a very clear trajectory, at least today. I think I have a clear trajectory of where I want to be 5 to 10 years from now. I felt like at that time, moving into an organization where I knew there would be turmoil and consolidation and reorganization, that opportunity that I was interviewing for and that trajectory may not be the same by the time I walk through the door. And so I decided that wasn't the right time for me to go towards a particular trajectory. Today, I think the decision would be the same. And the reason being that I have very high confidence that SpaceX will not be acquired or consolidated from a merger perspective anytime soon. What I do appreciate about SpaceX that I don't know that I would get in a large organization is a lot of flexibility. It's a large organization that behaves like a small organization with regards to its organizational structure. The ideas come from the ground. I'd say the people on the ground frankly know more about the direction that a program needs to go than maybe the highest part of the organization. That's excluding Elon, more talking about the management structure. And so that ability to be on the ground forces and have an influence, and I think you would find that to be true for the majority of the engineers, is that they're at younger stages of their career, but they have a large of influence on how programs develop. Yes, there's some checks and balances. Yes, there's a reliability in institutional programs that make sure that people are doing the right things. Certainly there's managers, but there's a lot of influence. And I think that's something that I wanted a couple of years ago and that I still want today, is that ability to sort of drive technical direction even though you may not have absolute management authority. So I think the answer would be yes. My decision would be the same for those two reasons, that it's not a tumultuous environment that I perceive today, and because of the latitude that I have within the organization that may not be present in a much larger, more institutionalized organization. Okay.
I think that's all the questions.
All right.
Thank our guest one more time.
Thank you.
So that wraps up our event, everybody. I hope you enjoyed it, and I hope it gave everybody kind of a sense of normalcy, even if you were on the internet stream. And it also just goes to show that Dan and our guest speaker had an event 15 years ago, and it's those kinds of connections that are important, so that's why you want to stay part of IEEE. And, I really appreciate everybody getting on the stream and asking the questions they did. So I look forward to seeing you guys in future streams. Hopefully, we don't have to stream it much longer. And maybe the year and COVID will go away eventually. But thank you again, Dr. Poliski. Sorry, if I'm butchering that name or not? Okay. And yeah, so thanks for attending. Thank you, Dan, for helping me out. And thank you, Pei Jung, for lending that laptop.
Well, you talked for a long time. Are you dry?